Let's add an appropriate new method definition to the iShoppingCart service interface named deleteItem. Let's open the shopping cart service class and implement the code logic for the deleteItem method. If the HTTP response code returned from the server falls within the success range, we want code to execute that returns an object of type cartItemDTO to the calling code. If the call to the server is not successful, we want null to be returned to the calling code. Let's open the shopping cart base class within the Pages folder. Let's implement code for a method that handles a button click event. So this method will be called when a user clicks a delete button that we'll create in a bit in the shoppingcart.razor file. Let's appropriately call the deleteItem method on the shopping cart service object that will be injected into our Razor component at runtime. So this code will call the appropriate action method on the server side that will delete the relevant entity, cart item, from our database. So we want the results of this deletion operation to be reflected on the user interface, which means we need the shopping cart Razor component to re-render once the deletion operation has completed successfully. We could call the appropriate getItems method and retrieve all the relevant shopping cart items that are currently saved to our database for the relevant user and assign the results to the shopping cart items property. And the result of the deletion operation would then appropriately be reflected on the UI. However, we can implement code for a solution that will be more performant for this purpose than the solution that I've just expressed, i.e., that involves an additional call to the server-side code. We can reflect the results of a deletion operation on the UI by simply deleting the relevant cart item object from the client-side collection of cart items referenced by our shopping cart items property. By deleting the relevant item from the client-side collection, we are avoiding a trip, as it were, to the server side. This could result in a significant performance benefit. So let's create a private method responsible for removing the relevant item from the client-side shopping cart items collection. We first need a variable that references the object within the shopping cart items collection that we wish to delete. So let's create another private method that contains code for returning a specific object within the shopping cart items collection. Let's then call our new private method to return the object that we wish to delete from the shopping cart items collection to our remove cart item method. We can then implement code to delete the relevant item from the relevant client-side shopping cart items collection. But there is a problem with this at the moment. Our client-side collection stored within the shopping cart items property is currently of type IEnumerable. The IEnumerable type is fine for when we need to traverse through the items in the relevant collection, but we don't currently have an easy way available to us to remove an item from the relevant client-side collection. One solution to this problem is that we can change the type of our client-side collection to type list. We must also appropriately change the return type of the delete item method definition in the shopping cart service interface, and of course we must also appropriately change the return type for the implementation of this method in the shopping cart service class. Let's go back to the shopping cart base class and use the remove method on the shopping cart items collection, which is now of type list, to remove the relevant item from the relevant client-side collection. Let's appropriately call our remove cart item method from within the delete cart item _ click event handler method. Let's create the delete button within the shopping cart.razor file. Let's use Blazor's @onClick syntax to ensure that our delete cart item _ click functionality is triggered when the user clicks our new button. Let's run the code and test our method. Great. Okay, so I don't like this empty screen displayed to the user here when the user no longer has any cart items saved to the user's shopping cart. So let's ensure that status information is outputted to the user for the case where the user's shopping cart is empty. So we can do this by using the count method. So if the count method returns a value greater than 0, we can output the data contained within the shopping cart items property, as well as the relevant shopping cart summary information. Else, let's output a basic message to the user informing the user that the user's shopping cart is empty. Let's run the code. Great. So I think rather than display the text remove on the relevant button, I think the standard trash icon would look better. Let's use Font Awesome for this purpose. I'm going to use an appropriate CDN, Cloud Delivery Network link, to reference the relevant Font Awesome CSS file. So if we go to this website, we can copy the relevant link here, and we can then paste it into our index.html file in order to include Font Awesome icons within our application. We are now able to reference the Font Awesome trash icon like this to display the trash icon on our delete button. Excellent! I hope you have enjoyed this video. I look forward to presenting the next video in this series, where we'll continue to develop our shopping cart application. We are going to implement the update quantity functionality in the next video. This is the 7th part of a video series dedicated to building a shopping cart application using Blazor WebAssembly on .NET 6. So, in the previous part of this series, we created functionality whereby a user can delete an item from the user's shopping cart. In this video, we are going to create the functionality whereby a user is able to update the quantity of a particular product that has been placed within the user's shopping cart. A notable feature that we'll add is the showing and hiding of the Update QTY button. So we only want the Update QTY button to appear when the user changes the appropriate value in the field denoting the quantity of a particular item in the user's shopping cart. When the relevant field is changed, the relevant Update QTY button appears. Once the user has clicked the Update QTY button to update the quantity of a particular item in the user's shopping cart, we want the Update QTY button to disappear. To achieve the appropriate showing and hiding of the Update QTY button, we are going to invoke a JavaScript method. This brings us to an important question. How do we integrate JavaScript into our Blazor WebAssembly component? In this video, we are going to look at how we can use Blazor's JavaScript interoperability feature to interact with JavaScript code from within our Blazor WebAssembly component. We'll implement this functionality toward the end of the video, so please stick around to the end to learn about JavaScript interoperability with Blazor. To start with, let's create the server-side code for the Update QTY functionality. So let's get started. Let's go to the shoponline.api project. Let's open the shopping cart repository class. Let's implement the code logic for the Update QTY method. First thing to do is reference the item that we wish to update. So if we are able to find the relevant item within our database, and therefore the item variable will not be null, we can then update the QTY field with the value passed in from the client. And to commit the change to the database, we must of course call the SaveChangesAsync method. Let's write code to return null to the calling client for when the item is not found within the database. Let's expose the update quantity functionality to our calling client through an action method. Let's open the shopping cart controller class. Let's create an action method named UpdateQTY. Let's appropriately call the UpdateQTY method on the shopping cart repository object to update the relevant resource with the QTY value passed into our action method by the client. Let's use our convertToDTO method to appropriately convert the cart item object into an object of type cartItemDTO. We can then write code to return the relevant object of type cartItemDTO to the calling client, along with the HTTP code status of 200 OK. Let's include the appropriate exception handling code. So we have so far created action methods that correspond to the HTTP get verb, the HTTP post verb, and the HTTP delete verb. The other two most common HTTP verbs are the HTTP put verb and the HTTP patch verb. The HTTP put verb and the HTTP patch verb are both associated with the performance of resource updates. The difference between these two HTTP verbs is that the HTTP put verb is associated with action methods that modify a resource, where the client sends data that updates the entire resource. The HTTP patch verb, however, is associated with action methods that partially update the respective resource. So we want our update QTY method to update only the QTY field for a cart item resource. So this means it is appropriate to associate our update QTY action method with the HTTP patch verb. We can write declarative code to indicate that this action method is associated with the HTTP patch verb. To do this, we can appropriately decorate the update QTY action method with the HTTP patch attribute, like this. Note that we are passing in data to the HTTP patch attribute that provides necessary route template information. This indicates that the URI for the relevant endpoint must appropriately contain the ID of the resource that the client wishes to modify. Right, let's write the appropriate code for the blazor component. So let's go to the shoponline.web project. Let's open the iShoppingCart service class. Let's open the shopping cart service class to implement the code logic for the update QTY method. Let's first serialize the DTO that we wish to pass to the server into JSON format. Let's create an object of type string content so that we can appropriately pass the relevant data in the appropriate format to the server. Let's call the patch async method on our HTTP client object and pass in the appropriate URI. As well as the relevant data to the patch async method. If the HTTP response status code falls within the success range, let's include code that returns the appropriate data returned from the server to the calling code. Let's go to the shopping cart base class. Let's create a method that will handle the update QTY button click event. So the calling code will pass in the ID of the shopping cart item that the user wishes to update, as well as the relevant quantity value. If the quantity value is greater than 0, meaning that the quantity or QTY field value is valid, we can appropriately call the update QTY method on the shopping cart service object to call the relevant server-side code in order to update the database appropriately. Else, if the calling code passes in an invalid quantity, let's set the quantity field for the relevant cart item to 1. Let's go to the shopping cart.razor file. Let's add an input field that will allow a user to modify the quantity of a particular item in the user's shopping cart. Note that we are using blazor's @bind syntax to bind each quantity input field to the corresponding property of the appropriate object of type cart item DTO stored within the shopping cart items collection. This means, for example, that if the QTY property for a cart item DTO object stored within the shopping cart items collection is modified, that this modification will immediately be reflected on the UI in the appropriate quantity input field. Let's create the Update QTY button that a user can click in order to update the quantity of a particular item. Let's use blazor's @onClick syntax to call the appropriate event handler method that we have created within the shopping cart base class. Let's stand by our convention to use the _click suffix for these type of event handler methods. So let's change the name of the relevant method from update QTY cart item to update QTY cart item _click. Then we can write code to pass in the appropriate values to our update QTY cart item _click method. Let's test the code. Great! So we haven't yet written code so that the total quantity and total price is reflected within the cart item summary information displayed to the user on the right-hand side of the user's screen. Let's implement the code for this. So firstly, let's include two properties within our shopping cart base class. Let's include a property to store the total price of the items within the user's shopping cart and the total quantity of the items stored within the user's shopping cart. Let's create a private method named setTotalPrice, which is responsible for calculating the total price of all the items stored within the user's shopping cart and assigning the result of this calculation to the relevant property. Let's create a private method named setTotalQuantity, which is responsible for calculating the total quantity of items stored within the user's shopping cart and assigning the result of this calculation to the relevant property. Let's create a private method named calculateCartItemSummaryTotals. Let's call the setTotalPrice method as well as the setTotalQuantity method from within the calculateCartSummaryTotals method. We want the total price of all the items stored within the user's shopping cart as well as the total quantity of items stored within the user's shopping cart to be reflected on the UI whenever a user action results in the state of the shopping cart changing. So let's appropriately call our calculateCartSummaryTotals method from within the updateQTY_CartItem_click event handler method. The deleteCartItem_click event handler method, and the onInitialized async method that is called when the razor component is rendered. Let's go to the shoppingcart.razor file and implement the code that will result in the appropriate summary totals being reflected appropriately on the UI. Before we run the code, we must also include a method in the shopping cart base class that updates the total price property on the relevant object of type CartItemDTO when the relevant quantity property is updated for a particular cart item by the user. So basically, if, for example, a cart item has a price of $50 and the user updates its quantity property from 1 to 2, we need to change the cart item's total price from $50 to $100. To calculate the total price is simply a mathematical operation of price multiplied by quantity. So let's create a method named updateItemTotalPrice. Let's call our getCartItemPrivate method to reference the relevant cart item. Then we can update its total price property with the result of the calculation that we have just discussed. We want our updateItemTotalPrice method invoked every time the quantity for an item within the user's shopping cart changes. So let's implement the code for this appropriately. Great. Let's run the code. Excellent. So let's look at JavaScript interoperability in a Blazor WebAssembly component. Let's implement the code so that our Update QTY button is only shown to the user when the state of the relevant input field changes. So let's first create a CSS file for our shopping cart razor component. So let's create a CSS file named shoppingcart.razor.css. As discussed, when we create a CSS file that only applies to a specific razor component, we must adhere to a specific naming convention. Let's create a CSS class named update-qty that contains the code display:_none. So we can apply this class to the Update QTY button like this to ensure that when the relevant razor component first loads, that the Update QTY button is not displayed to the user. So the next step is to create a JavaScript method that is invoked when the quantity input field is changed by the user. This JavaScript method will be responsible for appropriately showing and hiding the relevant Update QTY button. Let's create a folder within the www root folder of our project named JS. Let's add a JavaScript file named shoppingcartfunctions.js to the JS folder. Let's create a JavaScript function named makeUpdateQTY button visible. This function accepts two arguments. One denotes the ID of the relevant cart item, and the other denotes a Boolean value. So in order to be able to identify the relevant button within our JavaScript code, we can apply a data attribute to the relevant HTML element. So let's go to our shoppingcart.razor file and include a data attribute named data-item ID and set its value to the ID of the relevant cart item. The code for the JavaScript function is fairly basic. Let's use our data attribute to reference the appropriate button element. We are using the data-item ID data attribute to identify a specific Update QTY button. If the Boolean value is true, we want code to execute within our JavaScript function to make the relevant button visible. If the Boolean value is false, we want our function to make the relevant button invisible. Let's appropriately reference our new JavaScript file from within the index.html file. Then we need to write code to detect when a quantity input field or QTY input field is changed by the user. We can use Blazor's @onInput syntax for this purpose. One might think that the @onChange syntax should be used for this purpose, but a method executed in response to the @onChange syntax will only be invoked when the relevant input field loses focus. We want our method to be invoked immediately when the relevant input field's value changes. So let's implement a method within the shoppingcartbase.cs class that will be invoked when a quantity input field is changed. So we want our makeUpdateQty button visible JavaScript function to be invoked when a quantity input field is changed. So how can we call a JavaScript function from within a Razor component? The answer to this is that we can use the built-in JS runtime type for this purpose. So let's create a property of type IJS runtime. Let's decorate this property with the inject attribute so that an appropriate object of type IJS runtime will be injected into our Razor component at runtime. We can then use the object to appropriately call our makeUpdateQty button visible JavaScript function like this. Let's go to our shoppingcart.razor file and appropriately call our updateQty_input method. Lastly, let's write code that calls the relevant JavaScript function to make the relevant updateQty button disappear once the relevant button has been clicked. Let's run the code. Excellent. This is the 8th part of a video series dedicated to building a shopping cart application using Blazor WebAssembly on .NET 6. So at this point we have achieved quite a lot. We have created the functionality for displaying grouped products to the user. We have also created most of the functionality for the shopping cart. A user can now add a product to the shopping cart, remove a product from the shopping cart, and can update the quantity of a product that is contained within the shopping cart. So we now need a way for a user to be able to navigate to the shopping cart from anywhere within the application. We also want the user to be able to see at a glance how many items are currently contained within the user's shopping cart. Currently, the user is only able to navigate to the shopping cart through our application by adding a product to the shopping cart. We want the user to be able to see how many items have been added to the user's shopping cart at a glance, no matter where the user is within the application. For example, the user may be viewing the grouped products displayed to the user when the application is first launched and wishes to know how many items are currently contained within the user's shopping cart. We also want the user to be able to navigate to the user's shopping cart through our application from anywhere within the application simply by clicking a button. So we want to make this button accessible to the user from anywhere in the application. So in this video, we'll provide an appropriate solution for this. We'll provide a button in the header part of the UI that, when clicked, will navigate the user to the user's shopping cart. The quantity of items stored within the user's shopping cart will be displayed on the text of the relevant button. So the quantity value displayed on the relevant button must be kept up to date. So we must facilitate the change of the relevant quantity value whenever the number of items within the shopping cart changes. The code for the button containing the text representing the number of items in the user's shopping cart will be contained within its own Razor component, a Razor component we'll name Cart Menu. So this means we need to find a way to send data to the Cart Menu Razor component from other relevant Razor components, like for example, the Shopping Cart Razor component, whereby code must execute that updates the relevant quantity value when a change to the number of items stored within the user's shopping cart is made. In this video, we'll see how C# events can be used to facilitate communication of data between the loosely coupled Razor components within our application. Right, let's get started. Let's go to our Blazor client component. So let's go to the project named shoponline.web. Let's open the iShoppingCart service file. Let's create a definition for a C# event. Note that the action type is a delegate that doesn't return a value. So any method that the relevant delegate points to will be able to accept the arguments defined within the relevant delegate, but the method will not return a value. In our case, any method pointed to by this delegate will accept one argument of type integer. Let's create a definition for a method that is responsible for raising the relevant event to subscribed components. If what we are doing here is unclear to you, don't worry. It will become clearer to you as we develop the code in this video. Okay, so let's open the shopping cart service file. Let's implement the code for the interface items that we have just created. Let's implement the code for the raise event on shopping cart changed method. First, we need to check if our event has any subscribers. We can do this by evaluating the onShoppingCartChanged event object. So if the onShoppingCartChanged object is not null, this means that the event has subscribers. So if the event has subscribers, we need to write code that raises the event to those subscribers. We can do this by implementing the invoke method on the onShoppingCartChanged event object. Then we can send the appropriate integer value to each of our subscribers by passing in the appropriate integer value to the invoke method. So in the context of our application, an example of a subscriber will be a method within the cart menu Razor component that we'll create later in this tutorial. When the quantity of the items stored within the user's shopping cart changes, the event is raised and a custom method that will be created within the cart menu Razor component will be invoked in response to the quantity of items stored within the shopping cart changing. Basically, when the quantity of the shopping cart changes, the event is raised and any subscribed methods are called. This will be clarified with code that we'll create in a bit. So this event being raised will result in the new quantity of items stored within the user's shopping cart being displayed from within the cart menu Razor component. Let's open the productsbase.cs file. Let's write code so that an object of type shopping cart service will be injected into this Razor component at runtime. So the product Razor component is loaded when a user first launches our application. We want the user to be able to see how many items are currently stored within the user's shopping cart when the application is first loaded. So let's first appropriately call code on the server to retrieve the shopping cart items currently stored within the user's shopping cart. I can feel the comments flowing my way already. So I think I'll be preemptive and just say that I'm aware that this may not be the most performant way of doing this. But I want to focus on events in relation to Razor components in this tutorial. We will be optimizing the code in later videos. For example, by including local storage functionality. I don't want to make my videos too convoluted, so this is why I sometimes first create simplistic code in certain scenarios so that momentum is gained in the development of our application. And then, as I said, we can always optimize the code in later tutorials. Right, let's write code to calculate the number of items currently stored within the user's shopping cart. We can then use the shopping cart service object to raise the appropriate event, which will in effect send the quantity of items stored within the user's shopping cart to any subscribers. So this will result in the appropriate quantity value being displayed to the user in the header section of the layout of our application. Let's open the shoppingcartbase.cs file. So we want our event to be raised each time the quantity of items stored within the user's shopping cart changes. Let's create a private method named cartChanged. Let's rationalize our code a bit so that the cart summary totals private method is called whenever this cartChanged method is called. And we want our event to be raised whenever the cartChanged method is called. We want our cartChanged method to be called whenever the state of the user's shopping cart is changed. So let's appropriately call our method from within the onInitialized async method. The delete cart item underscore click event handler method, and the update qty cart item underscore click event handler method. Notice that each time we write code to invoke the cartChanged method, we are replacing the call to the cart summary totals method with the call to our new cartChanged method, because the calculate summary totals method is now being called from within the cartChanged method. So let's create the code for the cart menu Razor component. This component will be displayed in the header section of our layout for our application. So let's create a Razor component called cartMenu.razor within the shared folder. Let's write code so that an object of type iShoppingCartService is injected into our cart menu Razor component at runtime. Let's open the underscore imports.razor file and include a using directive that references the shoponline.web.services.contracts namespace. So we are not using inheritance for this component. So we can instead include code logic for this Razor component within the @code section of our Razor file. This is because our cart menu Razor component is not likely to contain a lot of code logic, so we don't necessarily need to abstract the code logic into a separate base class. Let's define a variable of type integer named shopping cart item count. Let's create an override for the Razor component's onInitialized method. This method will be called when our Razor component is first rendered. So we want our Razor component to subscribe to the event that we created in the shopping cart service class. To achieve this, we can implement this code. This means that every time the relevant event is raised, the shopping cart changed method will be run. So we haven't yet implemented code for the shopping cart changed method, so let's do that. So all we are doing is updating our shopping cart item count variable with the quantity value passed into this method from code that executes to raise the relevant event. Note that we are calling Blazor's built-in state has changed method here. This is an explicit way of telling Blazor, as it were, to re-render the relevant Razor component. So we are explicitly telling Blazor to re-render the component after the shopping cart item count variable has been assigned a new value from code that is raising the relevant event. The shopping cart item count will be used in the UI user interface code that we are about to create for displaying the new quantity of items stored within the user's shopping cart. So let's write the UI code, and this must exist outside the @code section. So we want a button displayed to the user that displays a value representing an up-to-date count of items currently stored within the user's shopping cart. We also want a user to be able to navigate to the user's shopping cart when this button is clicked. In order to prevent possible memory leaks, we can write code to unsubscribe from the onShoppingCart changed event. So to do this, let's implement the iDisposable interface. Then we can implement code for the dispose method to unsubscribe from the onShoppingCart changed event like this. So you can see that the plus equals operator is used to subscribe to an event, and the minus equals operator is used to unsubscribe from an event. Let's open the main layout Razor component from within the shared folder. This component is responsible for displaying the main UI layout of our application. We can ensure that our cart menu Razor component displays within the header section by including the appropriate tag for our cart menu Razor component here. So let's run the code. Excellent. So notice that when we are using a mobile view, when running the application, we are not able to see our header menu item. So let's write code to allow for users that are using our application in a mobile view to be able to see the count of items currently stored within the user's shopping cart, and also to be able to navigate to the user's shopping cart from anywhere within the application. We can do this by adding an appropriate menu item to the application's main menu for when the application is being used using a mobile view. So let's open the nav menu.razor file from within the shared directory. This file contains the code responsible for creating our application's main menu. Let's add a new menu item to the main menu like this. Let's write code so that an object of type iShoppingCartService is injected into this Razor component at runtime. In the @code section, let's create a private variable of type integer named shoppingcartitemsCount. Let's implement the code to subscribe to the onShoppingCartChanged event. Let's implement the method that we want executed when the onShoppingCartChanged event is raised. Let's go to the appropriate menu item code and include the shopping cart item count variable so that the user is able to see from this menu item how many items are currently stored within the user's shopping cart. Now, we only want this menu item to be shown to users that are using our application using a mobile view. So we can ensure this by including the d-sm-none bootstrap class within the appropriate HTML element that represents the relevant menu item. Lastly, let's write code so that before this Razor component is garbage collected, i.e. before .NET frees the memory taken up by this Razor component, that the relevant method within this Razor component is unsubscribed from the onShoppingCartChanged event. Let's run the code. Excellent. So we have now completed all the functionality that enables a user to add items to the user's shopping cart, as well as remove items from the user's shopping cart. A user is also able to update the quantity of products within the user's shopping cart. So, of course, no point leaving the products hanging around in the user's shopping cart. The next logical step is for a user to purchase the products in the user's shopping cart. So, we are going to create a Razor component in this part of the course that denotes a checkout facility, whereby the user can purchase the products within the user's shopping cart. So, how do we create a payment facility so that users can purchase the items in the user's shopping cart? The answer is we must integrate a payment gateway into our application. So, if we navigate to this website, we can see here some useful information regarding payment gateways. What is a payment gateway? A payment gateway is a service that authorizes and processes debit/credit card or PayPal payments for online merchants and traditional brick-and-mortar businesses. A payment gateway facilitates these transactions by encrypting sensitive data and transferring it between a payment portal, a website or a mobile device, and the bank/front-end processor. If we scroll further down this page, we can see a list of the most popular payment gateway providers. You've probably heard of a few of them, like for example PayPal and Stripe. PayPal, Stripe, Square, SecurePay, WorldPay, Authorized.net, ToCheckout.com, Braintree. I have a business account with PayPal, so I'm most familiar with PayPal. In this video, I'll give you a very basic guide on how you can integrate the PayPal payment gateway into your application. Even though I'm specifically using PayPal, the same fundamental principles will apply for other payment gateways. Please see the relevant instructions provided by your preferred payment gateway service provider on how you can integrate your preferred payment gateway into your applications. The payment gateway service provider will provide developers with information on how to integrate the relevant payment gateway into your application. It's not as difficult as you might think. All of the heavy lifting, as it were, is done through the third-party payment gateway. So, this tutorial is not a definitive or comprehensive guide on how to integrate a payment gateway into your application, but it will hopefully give you a very good idea of how to integrate a payment gateway into your applications. It all depends on your application's requirement on how you go about implementing relevant payment gateway integration functionality in your applications. Let me first present a brief disclaimer before we start this tutorial. This is not a definitive guide on integrating a payment gateway into your application. This is certainly not a final e-commerce solution. The purpose of this tutorial serves to give you a basic idea of how you are able to integrate a payment gateway into a Blazor WebAssembly application. If you wish to create an application that uses a payment gateway in a live environment, you'll need to research relevant information provided by your preferred payment gateway provider in order to gain a thorough understanding of how to create an e-commerce solution using the relevant payment gateway. Right, let's get started. Let's create a Razor component named checkout.razor within the Pages folder. Let's create a C# class named checkoutbase.cs within the Pages folder. Let's write code to ensure that the Checkout Razor component inherits from the Checkout Base class. As the name of our Razor component suggests, a user will navigate to this Razor component in order to purchase the items within the user's shopping cart. PayPal makes it easy for us to integrate the payment gateway functionality within our applications by providing us with sample HTML and JavaScript code. In order to copy the relevant HTML and JavaScript code, let's navigate to this PayPal web page. If we scroll further down the page, PayPal presents us with a few options. I'm going to use the first option here. Let's click the Start Setup button. Let's select the variable price list item here. Let's select the desktop option here. Then to copy the relevant JavaScript and HTML code, we can click the Copy Code button here. Let's navigate to our index.html page and paste the HTML and JavaScript code currently stored within our clipboards here. You can see here we have a JavaScript function named init PayPal button. This method contains callback methods like, for example, create order, and onApproved. The create order method is called by PayPal when an order is created, and the onApproved method is called after the relevant order has been approved by PayPal. Note that within the onApproved method, there is code that logs information about the order which is sent back from PayPal after an order has been approved to the browser console window. The relevant information is sent back from PayPal regarding the relevant order after the order has been approved by PayPal. So this gives us an idea of how our code integrates with PayPal. We also have a script tag here that references a script file at a specific PayPal location. The way in which we are able to link a PayPal account to our application is through this client-id parameter here. At the moment, we only have a placeholder value for the client-id parameter. I'll demonstrate a bit later how we are able to generate a valid client ID value that we can paste over this placeholder value here. I'll demonstrate this a bit later. We have this HTML code here that contains various fields and a placeholder for the relevant payment gateway related buttons that the user can use to start the payment process. The user will be able to pay using a valid debit or credit card by clicking this button, or if the user has a valid PayPal account, the user can use the user's PayPal account by clicking this button. For a particular integration requirement, we can tailor the sample code to our needs. So we are going to simplify the code here and remove code that is superfluous in relation to our particular requirement. So let's say that for a particular integration requirement, we only need the description field and the amount field. So we can delete the JavaScript code from the init PayPal button method here that references the HTML elements denoting the fields that we don't need. We don't need this code here, so let's delete it. We don't need this code because it is code used for validating user input. Code within our application will control what is entered into the appropriate fields, namely the amount field and the description field. Therefore, we don't need any user validation related code. In the onInit method, there is a lot of code relevant to user validation that we don't need. Let's delete the onInit method. Within the onClick method, we only need this code here that references the values that will be inserted into the amount and description fields at an appropriate time by certain code within our application. So let's copy the relevant code from the onClick method here. Let's paste it into the create order method here. Then we can simply delete the onClick method. You can see here in the onApproved method, we have code here that logs order information to the user's browser console window. This information is sent back from PayPal once a user's order has been approved by PayPal and contains details about the user's order. We'll examine the order information later when we test our code. You can see here that the sample code that we copied from PayPal includes a call to the init PayPal button JavaScript method. We want to control when the init PayPal button method is invoked. We'll implement the code to call the init PayPal button method using C# code and Blazor's JavaScript interoperability feature from within the Checkout Razor component in a bit. So let's remove the call to the init PayPal button from the index.html file. Let's cut this HTML code here and paste it into our checkout.razor file. This will allow the PayPal buttons to be available to the user when the user invokes the Checkout Razor component. For our particular requirement, let's say that all we are interested in is the description field and the amount field. So let's remove the HTML elements that we don't need for the implementation of our integration code with PayPal. We don't need the HTML elements that label the relevant fields, because we are going to make the amount field and description field hidden text fields. We don't want the user to enter any payment information. We are going to control the values that are inserted into these fields through C# code that we'll implement in a bit. We need this div element here because this tells PayPal, as it were, where we want the relevant PayPal gateway-related buttons placed within our UI. So, for our requirement, we don't want these fields to be visible to the user. So let's make these fields hidden text fields. So let's create the code for the checkout-base.cs class. We are going to want to call the init PayPal button JavaScript method that resides within our index.html file from within the checkout-base.cs class. So we need to write code that ensures that an object of type IJS runtime is injected into our checkout razor component at runtime. This is so that we can utilize Blazor's JavaScript interoperability feature to call the init PayPal button JavaScript method that we copied from the relevant PayPal web page earlier. We'll write the code to call this JavaScript method in a bit. We need to reference the collection of shopping cart items, so let's create a property of type IEnumerable that is strongly typed with the cart item DTO type. Let's create a property named TotalQTY. Let's create a property named Payment Description. Let's create a property named Payment Amount. Let's create code to bind the PayPal-related hidden text fields we have implemented within the checkout.razor file to their counterpart properties by using Blazor's @bind syntax. So this means that every time relevant property values change, Blazor will automatically update their counterpart input fields, i.e. the input fields that contain the relevant @bind syntax in the checkout.razor file. The payment description and payment amount properties will be bound to the input fields implemented within the checkout.razor file. So this is one of the aspects involved in integrating our application with PayPal. We can communicate the total payment amount to PayPal through the payment amount property, and we can communicate whatever payment description we want by updating the payment description property. The JavaScript within the init PayPal button method references the fields that we have implemented using hidden text fields in the checkout.razor file, i.e. the amount field and the description field. The fields are bound to their counterpart properties within the checkout base class. We can use this description field to uniquely identify a particular payment. There are, of course, many different ways to implement this type of functionality. I've chosen this way for the sake of the example, in the interests of keeping the example simple, i.e. for teaching purposes. When we run the code and create a test order, once our order is approved by PayPal, we'll be able to inspect the data within our browser's console window, which is the data sent back from PayPal after our order has been approved. We'll see that one of the fields contains our unique description value. We want an object of type iShoppingCartService to be injected into our checkout razor component at runtime. So let's create a property of type iShoppingCartService and ensure that it is decorated with the inject attribute. Let's override the onInitialized async method. Let's implement code to retrieve the user's shopping cart items. We'll look at code in a later tutorial whereby we can use local storage functionality so that we don't have to make so many calls to the server. We can use local storage to improve performance, but we'll write this code in a later tutorial. So I'm writing code to create a new GUID here so that we can use this GUID value to uniquely identify a particular order. Let's assign the total payment amount to the payment amount property. Let's assign the total quantity to the total QTY property. Let's create an identifier field so that we can uniquely identify a particular order. As I said earlier, I'm just doing this for the sake of this example. It is up to the developer to modify the appropriate code so that it is adapted appropriately in relation to the developer's particular requirement. So let's include an O for order, followed by the user's ID, and then followed by the unique GUID value within the payment description field. Let's override the onAfterRender async method. This method is called in response to the occurrence of a Blazor lifecycle event that occurs after the relevant Razor component is rendered. We can use the first render argument passed to this method to ensure that our code within this method is only fired once after our Razor component is first rendered. So, if first render is true, we want code to execute that uses our JS object to call the init PayPal button JavaScript method. So you can see how we are integrating our checkout Razor component with the sample JavaScript code that we included within the index.html file. This is, of course, the sample code we copied from PayPal, so as to perform our integration with their payment gateway. So the next step is to generate the client ID, whereby we can link our PayPal account to our application. So we need to do this through PayPal. Note that you are able to follow along with the next part of this tutorial, even if you just have a personal account with PayPal. You will, however, need a business account with PayPal if you wish to go live with the PayPal Payment Gateway functionality. PayPal provides a sandbox feature that we can use for development and testing purposes. But as I said, if you wish to go live, you'll need a PayPal business account. For instructions on how to create a PayPal business account, please navigate to this URL. So assuming you have a PayPal account, as stated, you are still able to follow along even if you just have a personal account and you don't have a business account. Let's log in to PayPal. Then let's click the developer menu option here so that we can use the sandbox feature to implement the server-side part of the integration functionality so that we can integrate the PayPal payment gateway into our application. You can then navigate to the dashboard like this. You can see here you have two options, one for Sandbox and the other for Live. We are going to use the Sandbox facility. If you want to go live with your PayPal payment gateway, you would use the Live facility. As discussed, you will need a PayPal business account before you are able to go live with the PayPal payment gateway. So to create the server-side functionality that we need in order to integrate the PayPal payment gateway into our application, click the Create App button. Let's give the app a sensible name and then create the app like this. We now have this client ID generated for us. And this is the key to how we can associate our client-side integration with our PayPal account. So let's copy this client ID value to our clipboards. Let's remain logged into PayPal, and let's appropriately paste the relevant client ID value to our index.html file here for the client-ID parameter. Great. While we are here, let's remove the enable-funding parameter here. Let's go back to PayPal. So, for testing purposes, PayPal allows us to generate mock credit card details. When we test our code, we are going to use the generated mock credit card details to make a test payment. We can generate mock credit card details by clicking the Credit Card Generator menu option here. And then I'm going to select the United Kingdom as my country first. And then to generate the mock credit card details, we can press the Generate Credit Card button here. So let's copy the relevant mock credit card details and save them somewhere, so that we can access them a little bit later when we test our application. Before we test the code, let's make sure that we can navigate from our shopping cart razor component to our checkout component. So to do this, let's appropriately update the code within our shopping cart.razor file. Then we must also ensure that we have an appropriate @page directive at the top of our checkout.razor file. A user needs to be able to navigate directly to the checkout razor component, so we must include appropriate root template information following the @page directive. And now we should be able to make a test payment through our application. Let's run the code. Let's add some items to our shopping cart. Let's proceed to checkout. Let's appropriately enter our mock credit card details along with some appropriate made-up data regarding personal information, like address and phone number. Excellent. Now, if we press F12 within our Chrome browsers, we can see the data sent back from PayPal. In the onApproved callback method defined within the init PayPal button method, we have code to log data sent back from PayPal after an approved order has been made. We could implement code that extracts the relevant data from the returned data from PayPal and update our application's database in an appropriate way, depending on our requirement. That functionality is beyond the scope of this course, but hopefully this gives you a good enough insight of how to integrate the PayPal functionality into your application. But please read the relevant developer-related information provided by your preferred payment gateway service provider for information on how to create relevant integration functionality that best suits your requirement. And you can see here our custom description value that we created earlier in code has been sent back from PayPal along with the other order information, which contains the user ID value and a GUID value that our code generates for each order that is sent to PayPal. So let's finish the code for our checkout razor component. Let's say that we want to display a summary of items that the user is purchasing on the checkout UI, next to the PayPal buttons. So let's write the code for this. Please note this code can be copied from the relevant GitHub repository. I've included the location of the relevant GitHub repository below in the description. Let's test the code. Excellent. This is the 10th part and the penultimate video in a video series dedicated to building a shopping cart application on .NET 6. So we are nearly finished building our shopping cart application. In this video, we are going to create functionality so that a user can filter the products in our store's product catalog by product category. We'll write code to query our database for all the product categories within our database and display them as menu items in the main menu contained within the sidebar section of our UI. When the user clicks one of the menu items denoting a product category, data representing the products related to that category will be appropriately displayed to the user. Right, let's get started. So in the first part of this course, we created our database through EF Core Code First migrations. A requirement to update the database's seed data or structure may arise, for example, due to a decision to include new functionality within the application, or perhaps just to correct a minor mistake made when the database was first created and seeded with data. Through EF Core Code First migrations, we have the agility that we need to make appropriate adjustments to our database during the development and testing phases of our application. So before we start writing code, we need to address a database-related requirement. We need to add a new column to the product categories database table where we can store relevant CSS code that denotes an icon used to represent a product category. We are, of course, going to use EF Core Code First migrations to address this requirement. So let's first update the product category entity class to include a new string property. And let's appropriately name our new property icon CSS. We are going to need an appropriate DTO, data transfer object, to house the data that we send back to the client for when a client makes a request to the server for a collection of product category data. So let's go to the shoponline.models project and create an appropriate class to represent the relevant DTO. Let's go back to the shoponline.api project. Before we generate the relevant migration code, let's open the shoponline DB context class and update the relevant code for seeding our database within the onModelCreating method. So here we are including relevant font awesome CSS classes within the new field named icon CSS. These classes will be appropriately referenced within our code to render appropriate icon images for each of the relevant product categories. So let's create our migration. And give it a sensible name. Great. Let's look at the migration code that we have just generated. Great. Let's run our migration through the update-database command. Excellent. So let's go to our shoponline.api project. So if we look at the product repository class, we can see that we have already written the code for returning a collection of product category objects. We need to expose this functionality to the relevant clients. So to do this, let's create an appropriate action method within the product controller class. Let's create an extension method to convert the collection of product category objects to a collection of product category DTO objects. This may seem like a pointless exercise, because the shape of the product category class is exactly the same as the shape of the product category DTO class. It is important to understand that even though this step may seem unnecessary, that we are doing this due to design best practices. Why is this a design best practice? In the future, a new requirement may arise, for example, where a client may require additional data to be returned from the relevant action method. We want to maintain a clear separation of concerns between the DTO classes and the corresponding entity classes. The reason for this is that the relevant DTO classes can evolve independently from the relevant entity classes if required, without affecting their counterpart entity classes. So, a DTO class can, for example, be extended without affecting its counterpart entity class. Let's finish off the code for our action method. Great. So let's go to the shoponline.web project and write the calling client code for retrieving a collection of product category data. Let's create the relevant service code. Let's add an appropriate method definition to the iProductService interface. Let's implement the code for the interface that we have just created. So our code in this method is appropriately requesting a collection of objects of type product category DTO from the server. Great. let's create a Razor component that will be responsible for outputting the product categories as menu items inside our Blazor application's main menu that resides within the sidebar section of our application's UI. So within the shared directory, let's create a Razor component named Product Categories Nav Menu. Let's create a class named Product Categories Nav Menu Base. Let's write code so that an object of type iProductService is injected into our Razor component at runtime. Let's create a property of type iEnumerable that is strongly typed with the product category DTO type. Let's create a string property named errorMessage. Let's override the onInitialized async method. Let's create code within the onInitialized async method that retrieves a collection of objects of type product category DTO from the server and assigns the returned collection to the product category DTO's property. Great. Let's implement the code for the product categories nav menu Razor file. So we need to create a using directive that references the shoponline.web.pages namespace. So let's add the appropriate using directive to the _imports.razor file. We are adding this using directive because we are going to add appropriate tags to the product categories nav menu Razor file that reference relevant child Razor components that have been added to the pages directory. For example, the display spinner child Razor component. So notice that we are creating a link that contains a category ID parameter. We'll later write code that uses this parameter value to query the server for a collection of product data that is related to a particular category denoted by the relevant category ID value. So we haven't yet written the code for the products by category Razor component. We'll write the code for this Razor component a bit later. This Razor component will contain code for displaying a collection of objects of type product DTO that are related to the category ID value that will be passed as a parameter to the products by category Razor component. So the next step is to reference our new Razor component from within the Razor component that contains the main menu that appears to the user in the sidebar of the UI. So let's add the appropriate tag to reference our product categories nav menu razor component. Let's run the code. And we can see that our product categories are now appearing as menu items within the sidebar. However, as you can see, the style of the product category menu items are different from the home menu item, because the code that produces the category menu item is contained within a different razor component. So to solve this, I'm simply going to copy the CSS code from the navmenu.razor.css file and paste it into a new CSS file that we must name product categories navmenu.razor.css. So this will result in the product category menu items being styled like the home menu item. So we are flagrantly violating the principle of dry, don't repeat yourself here. I'm doing this deliberately to keep up the momentum in creating the code for this application, so that I can effectively keep the focus on the aspects that are the subject of this part of the course. You can of course centralize the CSS code for the menu items in adherence with the principle of dry. However, for the reasons I've just explained, I won't address this issue in this part of the course. Great. So let's move on to create the code for filtering the products by category. Let's go back to the shoponline.api project. Let's go to the iProduct repository interface. Let's create a new method definition within the iProduct repository interface. The code that we'll implement for this method will be responsible for retrieving a collection of product data that is related to a particular product category. So let's implement the code for the method that we have just defined within the product repository class. Let's create an appropriate action method to expose this functionality to calling client code. Great. Right, let's go back to the shoponline.web project and implement the service-related code regarding the functionality for retrieving product data related to a particular category ID. Let's open the iProduct service interface and create an appropriate method definition. Let's implement the code logic for the method definition that we have just created. So here we are appropriately requesting a collection of objects of type product DTO that are related to a particular product category. Right, let's create a Razor component responsible for displaying the product data filtered by category on the UI. Let's name this Razor component products by category.razor. Let's create a class named products by category base. Let's implement the code for the products by category base class. Firstly, let's create a property that represents a parameter that will be passed into this Razor component. The value passed into this category ID parameter will be an appropriate category ID value. Note that we are able to declare that a property represents a parameter by decorating the relevant property with the parameter attribute. Let's create the other necessary properties for our Razor component. So, we want our collection of products to be retrieved for a particular category only when the category ID parameter is set. So we can do this by implementing our code within a method that is called by Blazor in response to a life cycle event occurring when our parameter value is set. So to achieve this, we are overriding a built-in Blazor method named onParametersSetAsync. So let's write the code within the onParametersSetAsync method. Our code simply retrieves the appropriate product data from the server based on the value passed into our category ID parameter. Let's write the appropriate UI code within the products-by-category.razor file. So let's first use the @page directive to appropriately declare the relevant root template information for our products-by-category razor component. Let's write code to inherit from the products-by-category base class. Let's implement the code logic. So as you can see, we can reuse our display products razor component that we created in a previous part of this course to display the relevant products data to the user. Let's run the code. Excellent! So you can see that our product category menu items appear differently when compared to the home menu item. So let's fix this in code so that our menu items are displayed in a consistent way to the user. Great. Let's finish off by adding an appropriate logo for our application. Excellent. I hope you have enjoyed this video. I look forward to presenting the final video in this series, where we'll optimize our code to potentially create better performance for our application. Hi and welcome. I'm Gavin Lon. This is the 11th and final part in a series of videos dedicated to building a shopping cart application using Blazor WebAssembly and Web API on .NET 6. So, we have now built our basic shopping cart application. But is software ever really 100% complete? At points, there may be bug fixes to make. We may need to upgrade our application with the latest technologies. A requirement may arise to improve the overall performance of the application. There may be parts of the application where UX, user experience, can be enhanced. In this video, we are going to look specifically at how we can improve the performance of our application by optimizing our code. There are two areas where we can potentially enhance the performance of our application. Item number 1. In the Web API component, we are currently making two separate queries to the database when retrieving product data. Our code is returning both product data and product category data to the calling client. To do this, we are currently calling two separate methods in the product repository class. One for retrieving details about the products from the products database table, and the other for retrieving details about the product categories from the product categories database table. So in this video, to potentially enhance performance, we are going to retrieve the product and category details through one query to the database instead of two. The other area where we can improve performance is by using local storage within the blazor component to store both the product data and shopping cart data, so that when our application needs to retrieve relevant product data or shopping cart data, our code can retrieve the relevant information from local storage, i.e. data stored on the client within the user's browser, as opposed to making a trip, as it were, to the server every time the relevant data needs to be retrieved. So basically, the travel time in retrieving the relevant data can be shortened in certain scenarios. The data can be retrieved on the client instead of the server. For content like this and much more, please consider subscribing, and please ring the bell so as to be notified of future content. If you like this video, please hit the like button, and please feel free to share this video with anyone you feel may benefit from its content. So let's attack the first item. Let's go to the shoponline.api project. Let's optimize the code on the server, where we can make one query to the database to retrieve both product information and related product category information, rather than use two separate queries for this purpose. So the first step is that we need to modify the class representing the product entity. So we must first add a public property to the product class that is of type product category. Let's add the foreign key attribute to our new product category property. We can then pass an appropriate string value to the foreign key attribute that is used for declaring which property in the product class must be used for joining the product entity to the product category entity. So this code will indicate to EF core, as it were, how we want to join the product entity to the product category entity. Let's go to the product repository class and first modify the getItem method to appropriately join the product entity to the product category entity in the relevant link query. So to do this, we can use the include method like this. We are establishing the join between the two entities through this lambda expression. Notice the product category property that we recently created within the product class. For this query, we only want to retrieve one item, so we can use the single or default async method to filter the product data based on the relevant product ID passed to this method. Then for the getItems method, the code is similar to the getItem method. But for the getItems method, we wish to return all the products that are currently stored in the products database table with the related product category information to the calling code. So we of course don't need to filter the data. So that means we don't need to use a method like the single or default async method in this query. Then the last method that we need to appropriately modify is the getItemsByCategory method. If we open the product controller class, we can see that we can now simplify the code here, but first we need to appropriately update the relevant extension methods responsible for converting objects of type product to objects of type product DTO. So let's first update the extension method that converts an individual product to type product DTO. Great. Then let's update the conversion extension method that converts a collection of objects of type product to a collection of objects of type product DTO. Great. We can now update the relevant action methods accordingly. We no longer need to query for the category items in a separate query that we are using here to get a collection of category items. So we've potentially improved performance of the server-side code through an appropriate code optimization exercise. We are only dealing with a small amount of data, so the performance improvement would probably be negligible. But if we were dealing with large amounts of data, the performance improvement would be more significant. So let's look at the second way that we can improve the performance of our application. The second way that we can improve the performance of our application involves an update to our Blazor component. So let's go to the shoponline.web project. Let's see how we can reduce the number of trips to the server we are currently making for retrieving relevant product and shopping cart data through the use of local storage. So, we could use JavaScript and Blazor's JavaScript interoperability feature and write our own local storage functionality. It turns out, though, we don't need to go to this kind of trouble, because someone has already made available a NuGet package that contains the local storage functionality we need. So let's invoke the NuGet Package Manager window. Let's search for local storage. And this is the package we want to install. So let's install the blazor.localstorage NuGet package. For more details regarding local storage, please navigate to this URL. Basically, the JavaScript local storage object allows you to save key value pairs in the browser. Note, the local storage object stores data with no expiration date. The data is not deleted when the browser is closed and are available for future sessions. So the local storage functionality provided to us within the blazor.localstorage NuGet package abstracts the JavaScript code for managing local storage. So we don't need to write the relevant JavaScript code ourselves. We are now going to create two services to encapsulate our local storage functionality. So let's first create an interface named iManageProducts Local Storage Service. Let's create two method definitions, like this. Let's create an appropriate method definition for a method named getCollection. Let's create an appropriate method definition for a method named removeCollection. Let's create an appropriate service class to implement the methods defined within the interface we have just created. Let's create a constructor whereby we indicate that we want an object of type iLocalStorageService and an object of type iProductService injected into our constructor at runtime. Note that the iLocalStorageService type is a type provided by the blazor.localStorage NuGet package that we have now installed. So this type will be used to implement the necessary local storage functionality. Let's create a private method named addCollection. This method simply retrieves the product data from the server and saves the relevant product data in the user's browser using local storage. Okay, let's create a string constant to store the key that will be used to identify the relevant value. In this case, the relevant value is a serialized collection of objects of type productDTO. Let's implement the code for the getCollection method. So this method first tries to retrieve the relevant data from local storage. If the relevant data does not exist in local storage, we can call the addCollection private method to retrieve the relevant data from the server and save the relevant data to the user's browser using local storage. The removeCollection method simply removes the relevant data stored within the user's browser using local storage. Right, let's create an interface within the contracts folder named iManageCartItems Local Storage Service. Let's create an appropriate method definition for a method named getCollection. Let's create an appropriate method definition for a method named saveCollection. Let's create an appropriate method definition for a method named removeCollection. Right, let's implement the relevant code for the interface that we have just created. So let's first create a class named ManageCartItems Local Storage Service. Let's create a constructor whereby we indicate that we want an object of type iLocalStorageService and an object of type iShoppingCartService injected into our constructor at runtime. Let's create a constant to store the key that will be used to identify the relevant item stored using local storage. The local storage item in this case will be a serialized collection of cart item DTO objects. Let's create a private method named addCollection. This method simply retrieves relevant data from the server and appropriately saves the data to local storage. This method attempts to retrieve the relevant data from local storage. If the relevant data does not exist in local storage, the code retrieves the relevant data from the server and appropriately saves the relevant data to local storage. Let's implement the code for the remove collection method, which involves appropriately deleting a collection of objects of type cart item DTO from local storage. Notice that the key constant is used to identify the relevant local storage item. Let's implement the code for the save collection method, which involves appropriately saving a collection of objects of type cart item DTO to local storage. So we haven't yet registered the iLocalStorage service type provided in the blazor.localStorage package with the dependency injection system. So let's open our program.cs file and apply the code to register the iLocalStorage service type for dependency injection. So we can use the add blazor local storage extension method for this purpose. We must then also register our two new service classes that we have created to abstract the relevant local storage functionality with the dependency injection system. So let's now implement the relevant local storage functionality within the relevant Razor components in order to hopefully increase the performance of our Blazor component. Let's open the product's base class. This is the base class for the Razor component that first loads when our application is first launched. Let's create the code to ensure that our two local storage services are injected into this Razor component. Let's say that when the product's Razor component is loaded, we want to clear the relevant local storage items from local storage. This will force our code to retrieve the relevant data from the server at this stage. Then subsequently, we want the relevant data retrieved from local storage to enhance performance. So let's create a private method named clearLocalStorage and use the relevant functionality we have created within the relevant services to remove the relevant data from local storage. Let's call this method from within the onInitialized async method. Then instead of going straight to the server for our data, let's use the appropriate local storage service object to first check to see if the relevant data resides within local storage. Of course, in this case, we are clearing the data before this method is called, which will force our code to retrieve the data from the server. However, our code will subsequently save the data retrieved from the server to local storage, which means that when other Razor components retrieve the relevant data, the data will be retrieved from local storage on the client side. which means an unnecessary trip to the server will be avoided. So this gives us an idea of how we are able to increase performance of our application using local storage. We can also use our Manage Cart Items Local Storage Service object to retrieve any cart item data that may be saved to the user's shopping cart, like this. So in this case, this code will retrieve the relevant data from the server and save the data to local storage. Any data retrieval of items within the user's shopping cart can then be done from local storage, and therefore trips to the server are saved and the performance of our application is potentially enhanced. Let's appropriately update the shopping cart razor component. Let's write the code so that an object of type iManageCartItems local storage service is injected into this razor component at runtime. In the onInitializedAsync method, let's replace the code that retrieves the relevant cart item data from the server to get the relevant data from local storage. When a user updates the quantity of a particular item saved within the user's shopping cart, we must update the relevant local storage item. This is because, of course, the relevant shopping cart has now changed. We can appropriately implement the save collection method for this purpose. We must also use the appropriate local storage service to implement the code to update the relevant local storage item when a user removes an item from the user's shopping cart. Let's implement the relevant local storage related code for the product details razor component. So this component is responsible for displaying details for a particular product. This razor component also contains functionality for adding a product to the user's shopping cart. Let's first create a private property to reference the shopping cart items collection here, because when the user adds a product to the user's shopping cart, we want our code to update the relevant local storage item. We no longer only want the code to update the relevant shopping cart on the server. We need to keep the client-side local storage data up to date as well. So let's first write code to update our shopping cart items private property with data retrieved from local storage within the onInitializedAsync method. So within the method responsible for adding a new item to the user's shopping cart, we need to write code that not only updates the data on the server, but also updates the relevant local storage item. So we can implement the desired functionality in code like this. We can also now implement code that gets data for an individual product from local storage Great. Let's appropriately update the products by category Razor component to include local storage functionality. Let's